A workstation contacts the same unfamiliar address every 60 seconds. Is it malware, a broken updater, or normal background traffic? Wireshark can show what crossed the network, but it cannot make the conclusion for you. Think of a packet capture as a security camera at one hallway intersection. It records who passed that point, in which direction, and when. It does not show every room, prove intent, or identify the person using a device. Useful investigations combine that camera view with other evidence. In this original CipherVibe guide, we will investigate a synthetic alert inside an owned lab. We will open a prepared capture, confirm capture context, find the busiest endpoints, narrow to one workstation, inspect DNS and TLS metadata, follow one conversation, build a timeline, and decide what to verify next. Capture only traffic you own or are explicitly authorized to inspect. Packet captures can contain credentials, personal data, session tokens, internal names, and confidential content. Our demo uses reserved documentation addresses and .example domains. No real user traffic, credentials, or malicious payload is included. Wireshark is a network protocol analyzer. It reads packets from a live interface or a saved capture file and uses protocol dissectors to label fields. The top pane is the packet list: number, time, source, destination, protocol, length, and a summary. The middle pane expands the selected packet into layers such as Ethernet, Internet Protocol, Transmission Control Protocol, Domain Name System, or Transport Layer Security. The bottom pane shows the underlying bytes. These panes answer different questions. The list reveals patterns. The protocol tree explains a selected packet. The bytes preserve the captured representation. A protocol label is Wireshark's interpretation of the available data, and that interpretation can be incomplete when traffic is truncated, encrypted, malformed, or running on an unusual port. Before analysis, record the capture source, interface or sensor, time zone, start and end times, snap length, dropped packet count if available, and authorization boundary. A capture from a workstation sees different traffic than a switch mirror, firewall, or cloud packet mirroring sensor. Capture filters and display filters are different. A capture filter decides which packets are collected and usually uses PCAP filter syntax. A display filter hides or shows packets already present and uses Wireshark's own field syntax. Use a capture filter when collection must be narrow because of storage, performance, privacy, or scope. But a filter that is too narrow can discard the context you later need. Use a display filter when you already have the evidence and want to explore it without changing the file. For incident work, preserve the original capture read-only, calculate a cryptographic hash, record who collected it and when, and analyze a working copy. Store captures securely and retain them only as long as policy requires. Do not run unrestricted captures on shared, workplace, hotel, or public networks without authorization. Promiscuous mode does not magically reveal every packet on a switched network, and visibility depends on interface placement, switching, virtualization, encryption, and sensor configuration. Our demo starts with a sanitized working copy named labsuspicioustraffic.pap. A beginner mistake is clicking through packets one by one. Start with the shape of the capture. Open statistics, then endpoints. Sort by packets and bytes. In our synthetic capture, the lab gateway is busiest, which is expected. Workstation 192.168.56.23 repeatedly communicates with reserved address 198.51.100.24. That relationship deserves review because it does not appear in the approved lab baseline. Next, open statistics, conversations. Each row represents one conversation with addresses, ports, packet counts, bytes, and timing. Sort by duration and packets. The repeated outbound sessions are small and regular rather than one long transfer. Statistics create leads, not verdicts. A busy endpoint may be a backup server. A rare endpoint may be critical. Compare volume, direction, timing, role, and baseline. Mark the workstation address, remote address, first observed time, last observed time, connection count, and sensor location in the investigation notebook. The display filter bar is where the investigation becomes focused. Enter IP.address, space, == space, 192.168.56.23. This shows packets where that address appears as a source or destination. Then filter on DNS to review name resolution traffic. Our workstation queries files -update.example. The .example top-level domain is reserved for documentation, so this is not a live domain. Next, use tls.handshake.type space == space 1. This finds TLS client hello messages in versions where the field is available. A client hello may reveal metadata such as a server name when it is present and not protected by newer privacy mechanisms. It does not reveal encrypted application content. Filters are version sensitive because protocol fields can change. The filter bar validates syntax as you type. If a field is unavailable, inspect the protocol tree and use Wireshark's current display filter reference rather than guessing. Save useful filters with descriptive names. Do not confuse a display filter with deletion. The hidden packets remain in the capture. Select one connection and note its TCP stream index. Apply tcp.stream space EQ space for our synthetic example. The exact stream number belongs only to this capture. The sequence begins with a DNS query for files -update.example. The response maps it to the reserved remote address. The workstation then completes a TCP three-way handshake, sends a TLS client hello, receives a server hello, and exchanges encrypted application data. The session closes, then a similar sequence returns about 60 seconds later. Follow TCP stream can isolate packets in the conversation and present captured stream data in order. With TLS, most application content remains encrypted unless the analyst has authorized session keys and a supported configuration. Now compare approaches. Wireshark is strong for packet timing, protocol fields, retransmissions, conversations, and what was visible at the sensor. Endpoint telemetry is stronger for process identity, parent-child relationships, file hashes, user context, and persistence. DNS and proxy logs can cover longer time periods. Firewall and flow records scale better when full packet capture is unavailable. In the lab, endpoint telemetry shows an approved inventory agent making the connections after a configuration error pointed it to a retired test service. The asset owner confirms the process and expected schedule. That evidence changes the assessment from suspected command and control behavior to a misconfiguration that still needs correction. If endpoint evidence instead showed an unknown and signed process, the response would escalate. Preserve evidence, isolate the host through approved procedures, block the destination where policy supports it, and begin incident response. Use Wireshark when packet-level truth matters. Use flow data for broad traffic patterns, logs for longer history, and endpoint tools for process attribution. The best investigation combines them. Wireshark's expert information summarizes anomalies and items of interest. It can help locate retransmissions, malformed packets, unusual responses, and protocol conditions. It is not an intrusion verdict. Retransmissions may indicate loss or latency. Reset packets may reflect normal application behavior. Encrypted traffic is normal. An unfamiliar domain may belong to a legitimate vendor. A large transfer may be a backup. Context determines significance. Common mistakes include capturing the wrong interface, ignoring time zones, using a capture filter that removes evidence, trusting automatic protocol labels blindly, overlooking packet loss at the sensor, exposing sensitive capture files, and following streams without a legitimate need. Do not upload organizational packet captures to public analysis sites unless policy and data owners explicitly permit it. Redaction is difficult because sensitive data can appear across layers and packets. When evidence is incomplete, say so. Record capture limitations, alternative explanations, confidence, and the next verification step. A reliable Wireshark investigation follows a repeatable path. Confirm authorization and capture context. Preserve and hash the original. Use endpoints and conversations to understand the shape of the traffic. Narrow with display filters. Inspect protocol fields. Follow only the conversation you need. Build a timestamped sequence. Then correlate network evidence with endpoint, DNS, proxy, firewall, asset, and owner data. Remember the hallway camera analogy. A packet capture shows what crossed one observation point. It does not show the entire building or prove intent. Your practical action is to create a small-owned lab capture containing one DNS lookup and one TLS connection. Record the sensor, time zone, endpoint, destination, filter, timeline, limitation, and conclusion. Then compare your result with the endpoint's process list or service logs. Useful packet analysis is not about finding the scariest-looking frame. It is about reducing uncertainty without overstating the evidence. This is original CipherVibe educational content. Capture and inspect only traffic you own or are explicitly authorized to analyze.